Hey guys, in this video I'm going to build Arduino tracker for battery which can track amps and voltage for cell. We'll store this information into comma separated values file, and then we will attach this file to Grafana and we will see graphs like that. So we can see very detailed information about cell voltage and amps going in or out from a battery. So to make this build, we'll need few components. First one is Arduino IDE. Second is a main component that is going to track all of this information is Adafruit INA 260. So basically this module is going to track amps going in or out from a cell and report this information. And then third component is optional. This is a small display. It's easy for debugging. We'll show this information on the display as well. So now when you're gonna look at these item connections, you will see that we have right here VCC power. We'll need to send 5 volts to this pin. Then we have ground, and then we have SCL and SDA. So we're going to use those two pins as well. And then for V plus and V positive and V negative, we're gonna solder a wire right here, which is going to be connected to our cell. So all amps is gonna go through these wires and it's going to measure this information. This device coming with a small attachment that you can solder this attachment and then just screw your wires. But in my case, I noticed if I'm sending more than 2 amps, because of like tiny legs, I have big voltage difference. So I will solder my wires directly to this item. Then if we look at the screen, what we have right here is connections. We have ground and VCCs, and then we have as well SCL and SDA. So basically same components that we see on this device right here. So to make connections, what we'll need to do is to parallel SDA from display to SDA from this sensor, and then SDA wire is gonna go to Arduino, where is an analog inputs to A4, and the SCL wires from SCL is gonna go to Arduino to connection to pin number A5 right here. So right now I'm just going to solder wires to this chip and then make all these connections. Okay, and now we can start making connections. So if you're not familiar with Arduino breadboard, right now on the top, this line represents negative, this is blue line, and the second line from the top, it represents positive. And then for connections on this part, all vertical lines connect together. So if I put a pin on a 35 right here and then put another pin right here, it's going to be a connection, so it's going to be connected right here. So now I need to connect negative first. So I'm using this pin to connect ground from display. Let's connect this to ground from Arduino right here, and then we'll connect this ground to this line. So right now we have all grounds connected. Same for positive connection. Okay, next step, I'm connecting SDA together on 2 boards. Okay, so at this point we have ground and positive paralleled and connected to this one, and SDA and SCL paralleled on 2 boards. Now we need to connect all of this to Arduino. So on Arduino, if we see right here, on this particular Arduino IDE, we can see that I can get 5 volts right on this pin, and ground is the next two pins. So I'm going to connect negative to ground, and another wire to positive side on a 5 volts right here. And now we can connect this to our breadboard. So positive and negative. And the last two connections we need to make is A4, which is right here, is gonna go through SDA. So let's just find where is SDA. So it's right here. And the A5 needs to go to SCL. Okay, so at this point we have all connections, and now we can connect our Arduino to our computer. Okay, and right here I'm using Mac machine, and I downloaded Arduino IDE. I will put link in the description. And now we can connect, we can power our Arduino to our computer. I would recommend to double check all wires connected to Arduino, otherwise we can burn our chip or board itself. So hopefully I did connections properly. Okay, so right now this is connected. Now let's jump to Arduino IDE. We need to flash all of this information to get code uploaded to Arduino. Okay, and right now we are in Arduino IDE, and here's a code that's responsible for tracking this information. Before we dive deep into this code, first step we need to do is to install Arduino spreadsheet library. So if you're gonna go to this link right here, which is going to be attached in the description, we can see information how to do this. Basically we need to download this tool, and then for installation we need to go on a Windows machine right here and just paste this folder, or on the Mac machine we can go to Documents, Arduino Tools, and drop this tool there, this folder there. After we're going to restart Arduino IDE, if we go to Tools, we will see that we have this Arduino spreadsheet. So now we need to install a few libraries to make it work with our microchip and display. So what we need to do is to go to Tools, Manage Libraries, and then in the Manage Libraries we will see this window where we need to install a few libraries. Maybe I will miss some libraries, but I will add them to the description. But first library is going to be INA 260. So if we search this library, we will see that it's installed on my machine, but hit install and install dependency as well. Then we will need the second library, which is SSD 1306. Yeah, this Adafruit SSD 1306, this is to make it work with display. And then third one is GFX. Yes, Adafruit GFX library. So install all of these three libraries and then we're good to go. So then we need to select our Arduino board. So if you go to port, right now my Arduino disconnected, my microphone connected to USB, is going to be USB port right here. And then we need to select board. So in my case, it's Arduino Uno. And then basically this is code which is responsible for tracking information. Let's go step by step what we're doing here. First step, we setting screen resolution. Then we basically initiating our display and our chip, which is actually 260. And then in a loop right here, this is where tracking is happening. So what we're doing, every 1 second you can do it as little as 100 milliseconds or even less, or you can delay this to 15 seconds or 1 minute, depends on what is your needs. And so basically we delay for 1 second, then we clear our display information, we set in cursor, and we printing information on a display. What is a bus voltage voltage and what is the current amperage. And now, second step, we printing into console, we're printing bus voltage, then comma, and current, our current. So basically this is what is going to be stored in a CSV file, comma separated values file. And now when all of this connected, we need to hit verify button, which is going to compile our code and make sure that we don't have any errors. And in my case, I do have errors by some reason. Okay, now I just define these variables before we use them. And now we can connect Arduino and hit this upload button. This is what I'm going to do right now. Okay guys, and when this sketch or code uploaded to Arduino, now we can see on Arduino that screen is displaying amperage and voltage. And if we go to tools, we have this Ardu spreadsheet right here. So if I just open this Arduino spreadsheet, we will see that we are tracking our information. So every second we're tracking voltage and amperage. Okay, and now we can connect our battery and see how values changing right there. To connect batteries, we need to do a few steps. First step, we need to connect battery negative with Arduino negative right here. So then on the chip we have voltage input positive and voltage input negative. So voltage input positive we need to connect to the battery, and at this point we will see that we start tracking our voltage for our cell. And as well, if we go to Arduino spreadsheet right here, we can see that we are tracking voltage right now. So now to track amperage, basically this second wire, V negative, this is where load or charging is gonna go. So in my case, if I take this resistance and put this on the negative side of the battery, let's see what's gonna happen. Right now we draw from battery 150 milliamps, and we see this 150 milliamps right here. Okay, and for example, if I'm going to charge my battery, so I have charger set it up right here to 366 volts. So I will add the negative to negative side of battery and connect these two parts. We will start charge our battery. So I can see that I'm pushing into battery 260 milliamps, and if I just reconnect this, okay, and I can see on Arduino that we're adding 0.28 amps, same value right here, and we are tracking this information right here. So at this point our tracker works. We can perform tests with our cell to charge or discharge this cell, and all of this information is going to be stored in a CSV file. And now when all of this works, let's jump to the next part, is how to build graphs using this information. I'm editing this video right now, and I noticed that it might be not clear how to connect charge and discharge right now to this microchip. So on this chip we have input and output. For input, it's this is marked as V input plus, and this V input plus should be connected to our battery positive terminal, and the second wire is V input minus. This is where our charge and discharge should be connected. So what we see right now on this frame, I'm holding this wire V input minus, and through resistor I'm connecting this to battery negative. So basically right now we discharge our batteries, and on monitor, if we zoom to our monitor, we will see that we have 150 milliamps value. So we draw from a battery 150 milliamps. So this is how we apply load. If you're gonna use any different load or inverter, for example, inverter negative is gonna go to battery negative terminal, and inverter positive is gonna go through this wire that I'm holding right now in my hand. When we want to charge our battery, right here is a power supply lab negative wire. This is wire connected to battery negative, and the positive wire from a battery is going to be connected to positive wire, which is going from this chip right here, V input minus. So right here I'm holding this in a hand, and as soon as I'm going to connect them together, right here we're going to track, so right here we're going to track that our screen right now is displaying negative value 0.29 amps, 290 milliamps, and this is how we charge in our battery. So this is just quick explanation how we connect load and the charge to our cell using this microchip. Okay, so the next step to build graphs, we need to save this information, and right here we have this save button. So if I just click on this, I'm going to save this on a desktop as an example, and it's going to create new example CSV file on a desktop. So now we can quit from Arduino. And the next step, we need to install Grafana. So Grafana is a tool that is going to help us to build these graphs. So here's a link how to install Grafana. You can go to system that you're using for Windows or Mac or Ubuntu, like select system that you're using and install Grafana. Okay, so the next step, we need to prepare our file for Grafana. So I'm using Sublime Text Editor. Okay, and right here all of this information. So right here I see that first line is corrupted, so I'm just going to remove this line, and then I'm going to add a header for this file. It's going to be time, then voltage, and last one amps or current. Okay, so we save this file, and now we can go to Grafana and install library to parse CSV information. So right here on this website, instructions how to install this on Linux, Mac OS or Windows. So basically follow these steps, how to install this CVS data source plugin. And then don't forget to go to configuration and search for Grafana config file. I will attach link to this Grafana config file, and then you will need to open this link in any text editor and paste these values at the end of this file. When this step is done, we can start using CSV files in the Grafana. And the next step, we can go to localhost, and right here is a welcome screen from Grafana. So just add your login and password. And now in the Grafana, we can add our data source, our file. So if I go to data sources right here, we can search for CSV, comma separated values. Okay, so for data source, hit local, give a name for this data source. So basically for file name, so example tracker, and provide path to your local file where it's located. Okay, when you hit save and test, you will see this success message. So now let's now go to dashboard and add new empty panel. So now in data source right here, select example tracker, and if you switch to table view, you will see all of this information from CSV file. And now to build this graph, we need to add these fields. So first field is going to be voltage. It's type number. Second is going to be current, type number, and the last one is our time right here, and select time there. So we have headers, make sure you select that one, and if you switch back from table view, theoretically we should see our information right here. So let me try to play with time right here. Okay, so I selected last 12 hours and now I can zoom to this event, and right here we can see that voltage is a green line and the current is a yellow line. And now we can see our graph for voltage and current. So let me just enable voltage, and you can see here that time when it happened and where the voltage of battery was at this point. So here's a voltage graph, and here's a current graph. So we can see that we discharged cell with 150 milliamps, and at this point we charged our cell with 280 millivolts. Okay guys, this was a quick video how to build this Arduino tracker. If you like this video, hit like button, and as always, thank you for watching and see you later.